you may already are familiar with to some extent. I'd like to show you a little bit of what we see in companies as sustainability becomes more and more important. As a company ourselves, our sustainability footprint is relatively small because we don't manufacture really big items. We don't have factories, we just do software. So the biggest impact that we can have is actually helping our customers to create a better building, a better car, whatever that may be. And our corporate vision is to help people imagine, design, and create a better world. And for us, a better world means that by 2050, 9 billion people can live within the means of this planet. This is a tremendous design challenge by itself. It's providing more for more people, but demanding less from the planet. So our interest is to provide tools that help our customers, companies, to make exactly that decision, a more sophisticated decision. Alright, so a couple of stats. These are just statistics that our customers currently are dealing with. So architects, property developers, manufacturing companies, everywhere really, right? So within 35 years, 2 billion people are moving into cities. What that means is in the next 20 to 30 years, we will build globally as many buildings as we have built in the last 4,000 years. So, if you're in property development, it's great. But it also means you need to go and make sure that the buildings that you build really help to make a better world. Right? This is a lot of buildings, a lot of infrastructure that will go into that. 34% of the world's population is currently online. That's a technology trend that we like as a company to make use of. 34 means that you also have a greater majority who is not online. Right? It speaks a little bit to the digital divide as well that we still face. 21% has a smartphone, and in some of the nations that are still grappling with development, smartphones actually can be a really good use of commerce as well. And that has an impact as well. In our instance, if you're a designer or engineer, if you go out into the field and you have a mobile tablet, you can actually make use of the cameras that inside and actually start planning as an architect in the field. So that's the benefit of this, because you can be connected, let's say, to the cloud and use cloud computing technologies. This is just an example, right? So if you make a simple line drawing and plan view, you can do this now in the field. You no longer are stuck on your desktop, which is also helping architects to make better buildings because you are on the ground and seeing the environment as well. And it might be useful for you when you go on your field trip. So for us, design is anybody really who intentionally shapes the world for the better. And when I say anybody, I really mean that. It's not just the architects and the designers and the engineers, but it's also the policymakers. It's the person who decides on resources, whether that's time, money, or people. There's an aspect to this, and more and more we see in the market that companies are making these decisions as you would make a design decision. I get into this in a little bit in a moment, a little bit more. So AutoDesk as a company, we provide software that helps in the built environment. Shanghai Tower was built or is almost being completed through the use of our tools, specifically in that shape to simulate wind flow in order to take care of the high winds that Shanghai can have. Tesla is another company that made use of software. Again, here the idea is obviously to make a revolution in the mobile transportation business. We are also in the film industry, so a lot of the technology that went into movies like Avatar, that visualization technology can be used in other industries as well. Everybody who is working on these projects, whether they're very small, if you are just printing something in a 3D printer, or if you make something for yourself, to this really large project that you've seen, everybody is a designer. And what we see is something that we call a design-led revolution. We identified 3 different principles that every project is focusing on, and that designers and engineers and architects are focusing on when they make products or when they build something. And more, we see this everywhere. And these are the challenges that these designers and engineers are really, everybody is really trying to focus on. These are global challenges that we call epic challenges. And epic challenges is something that is just enormously large. It's very complex. It's like a wicked problem. Something that is systems dependent, right? So you no longer can find a solution by yourself. You have to rely on others for the solution to be implemented. And if possible, you want to leverage that connection in order to create an even better solution. That's the only way you can change, bring about change and find solutions that solve these massive problems. And when we speak of these massive problems, and all of our customers in any field is really facing this, right? It's climate change. Why do we have such a cold winter? In Chinese New Year, we had 25 degrees. And the day after or so, it suddenly was 10 or 7. Right? So this is really unusual for Hong Kong. The East Coast had massive snow. Australia was so hot that the bats literally fell from the sky. I don't know if you've seen that. It was too hot for bats to fly during the day. They would die of heat strokes, and there are thousands of bats that literally fell out of the sky. If you talk about biblical, I mean, that's just massive. Whether that's climate change or whether that's other elements, for sure there is an element that we are responsible and that we should make a difference there. Health, water, urbanization. California right now has one of the longest droughts. So these are all issues that we will see. China will have a water issue as well. Australia has one. So these ones are also issues that we see worldwide. We call these epic challenges. Right? So the challenge is to provide for humanity more by demanding less from our planet. And so these are now the 3 different principles that we recognize and that we also want to tell you as a best practice. There are 3 different principles. Number one is called impact modeling. Impact modeling means that you can now have a greater insight of the impact of your product or your building before it's actually being built. Before you have the first digger come in and take out soil to build a foundation for a building, you already have the ability to understand what is the best performance for this building. Right? You can do conceptual energy analysis of a building and understand that by just shifting a building by 2 degrees, you have a more favorable fall, solar sunlight that comes into winter or summer and heating up the building or keeping it cool. These are sort of very important things. And what we call by impact modeling is that you can model inside a computer environment. Our CEO likes to say, you want to make the mistakes in bits, not in atoms. Once you make it in atom, you have a building fixed. It's costly to change it. But in bits, in the digital environment, you can change it as many times as you want. Simulation technologies and computational cloud computational capabilities enable you to really look at these things from a very sophisticated and educated point of view. Rapid iteration. This takes away the fear of failure. What it means is you want to iterate as many times as possible until you have the final best idea. Or you want to combine ideas. So this is again playing on this. We see this in many, many ways, from architects to manufacturing. More and more that what they're doing is they iterate as many times as quickly as possible. And there are ideas that sometimes they're called turkeys, or things that really just don't work and they're ridiculous, as we heard. earlier with Ken's presentation. But sometimes these are really good ideas, and sometimes even the ridiculous ideas have a notch or a hint of a solution that you can combine with something else. And then the other thing is massive collaboration. This is the third principle. Massive collaboration means that now you cannot just collaborate designer to designer or architect to architect. You can actually go out and see every single stakeholder that is going to be influenced by the building or by the product once it's real. That's from the user to the person who has to recycle it to the person who has to build it. All of this means you can now connect them. That's what we call massive collaboration. You want to connect. You want to understand the person who builds your building. Is there something that you can do differently that enhances his way of building it? The person who is recycling it, the person who is going to use it. So when you go onto your field trip, I would actually challenge you to go and identify the users and maybe have a conversation with them and see if there is something that you can gain out of this as well. So these are the three core principles: impact modeling, iteration, massive iteration, and massive collaboration across different disciplines. As actually Tony, you said at the beginning, that was the idea: cross-disciplinary collaboration, and that's very much in line. So I'm very happy to hear that. So one thing I wanted to show you now is two examples. They are not from the built environment, but these are companies, two examples out of thousands of companies that have taken these three concepts and built something that's really having an impact, and it's even a slightly different business model. And hopefully that will give you an inspiration as well to not just do the normal thing, as was Ken earlier said. You want to do something that's innovative. We actually support, we have a program, so I'm part of the corporate sustainability team. We actually have a program where we support clean technology innovators as well as non-profit organizations that could make use of our tools. We essentially give them software almost for free, for $50, $20. This is something that is when you are already outside of university. If you are, as a student, you actually have access to software as well. You should go and check autodesk.com/education. That is a good way to start and become part of the educational community, as long as you have an email address or a way of proving that you're a student, you have access to software and tutorials of all sorts. Okay, so this is the very first example. This is a company called BioLite. They traveled to sub-Saharan Africa and witnessed many people, actually it's about 3 billion people worldwide, who cook on open fires. Cooking on open fires means smoke inhalation, black carbon that's in the air. Actually there are 20 million premature deaths every year of smoking, of cooking over open fires through the smoke inhalation. So they said, let's do something for these people. And they developed this. You see this here on the left side, this stove. They call it a home stove. Let me go forward and backwards. There you go. And so this home stove is actually enabling communities to have a reduction of black smoke, of the smoke emissions by 95%, and uses 50% less wood. So that was already a very good thinking. So they looked at this and they used computational fluid dynamics to actually simulate the flow of heat and smoke to understand how can we optimize this to a level that people can really cook and don't have to inhale all that smoke. They went a step further. They realized that most people who need to cook on open fires don't have electricity. Well, obviously, otherwise if they would have a microwave maybe. But they are really living on a very low income level. The kids that are in these villages often don't have an ability to do homework after dark because there's no electricity, there's no light. So what they realized is there's excess energy that comes out of this. And they use the excess energy to actually create electricity that powers a fan the fan, in turn, enhances the effectiveness of the heat even more, but at the same time, it also is enough to power an LED light or charge your mobile phone. And many of these youth communities actually depend on, they're off-grid, right? They have a mobile phone and they use this to do comms. So this is a very strong and very good impactful idea. Now you wonder, how can you finance this? And here's a couple of other images. And so what they sell commercially in retail is this one here. This is a camp stove that you can buy on their websites. The proceeds of this purchase goes to the home stove that is then distributed in currently in sub-Saharan Africa, and they're looking to distribute it elsewhere. So a really different type of business model as well. And I thought it was a really good idea to maybe inspire you to think a little bit outside of the box. These guys did. There's a second example that I'd like to show you. There are, I think, about 30 million people worldwide that don't have the freedom of mobility. They have either to landmines or other ways, accidents, lost a limb, and are unable to really walk. So this is a person, his name is Kamal. Kamal lost his leg when he was 16 in a motorcycle accident, and basically had no job, no way of getting a job, was walking with a bamboo stick and basically dislocated his spine because of the odd walking positions that he had. So there's a company called DREV, it stands for Design Revolution, and they looked at this and said there must be a way that we can help this. And so they built a knee prosthesis, or a leg prosthesis for Kamal and for other people. Kamal was within one day able to walk, and he took actually a job in that same clinic delivering food to patients, something that he could have not done before. So what they did is, very similarly, they developed, this is the very first prototype that they've done. They developed this and realized by only using 8 parts, this one cost $13 US to make. If you go elsewhere in the developed world, in the US and Europe, it just costs thousands of dollars to have a really good knee prosthesis. And this is the second model that I've done. Again, minimal parts. It now has a rounded shape, so that when they wear pants, it actually looks like a knee, whereas the previous version didn't do that, right? And this is the second example that I wanted to explain to you about. While these examples may not be applicable to this particular project, I hope that it gave you a little bit of an idea of thinking outside of the box, thinking outside of the normal of renewable energy and solar panels and all that, but try to find something that is different, right? And the 3 core principles is maybe something that you can hopefully be using as well, right? And then lastly, I'd like to just leave you with a quote from Henry Ford, who said, whether you think you can or you can't, you're right. So that's, I'd like to leave you with, and wish you all the best of luck. Thank you again for inviting me, and I'd be happy to look forward for all the entries. It should be exciting. Thank you.